One of the things that I thought I could talk about last time, we kind of got into additive manufacturing and uh, I actually have a module in here about additive manufacturing, but I wanted to show one of the things that I'm spending a lot of time on in the next 2 days. I serve on a committee for the National Research Council that evaluates the National Institutes of Standards and Technologies, which is one of the laboratories of the Department of Commerce. And it turns out NIST, as it's called, used to be called the National Bureau of Standards. And their main headquarters north of Washington, D.C. is a big complex on about, I don't know, probably 50-acre site. And they have 1,000 scientists and people working on things that, various things. And as you walk into their main entrance, on the wall behind the entrance desk, it says, there's a picture of it. And this comes from a quote from the law incorporating the bill to begin the National Bureau of Standards in 1900, okay? It is therefore the unanimous opinion of your committee that no more essential aid could be given to manufacturing, commerce, the makers of scientific apparatus, the scientific work of the government, of schools, colleges, and universities than by the establishment of the institution proposed by this bill. And so they started the National Bureau of Standards, and then they changed their name about 10 or 15 years ago to the National Institute of Standards and Technology. And they claim to be the US government's laboratory dealing with competitiveness. And we're going to talk about competitiveness maybe on Friday, but certainly by sometime next week. And what productivity, the difference between productivity and competitiveness. Does anyone have any idea right now what the difference between productivity and competitiveness is? Well, productivity is measured in output per person hour of work. And so it's not necessarily easy to measure, but it's measured all the time. And they look at the productivity every 3 months of the United States, and they say whether the economy is improving or going down or whatever in terms of the productivity of the United States. And the economists spend lots of time measuring productivity, output per person hour. And on Friday, Suzuki-san is going to talk about the steel industry. After he gives his, because he's been in the steel industry for 10 or 15 years. He's over here from Nippon Steel, getting a graduate degree at MIT in materials. And the Japanese steel industry, all steel industries right now, are facing tremendous pressure from China. And I don't know how much, I don't want to steal some of his thunder, but it turns out the steel industry used to be, until 1962, the standard by which every country measured the value of their money, basically. Back 200 years ago, money was valued on the productivity of agriculture. How many potatoes, bushels of wheat, or whatever a single person could produce. It was an agricultural economy. And then we had the Industrial Revolution in the 19th century. And it turns out, starting about 1880, steel took over as the thing that everybody measured. All the economists measured the steel output of various countries. And at that time, the British, I think the British in the 1880s were the largest steel producing country. But then this guy, Andrew Carnegie, came along, and sometime probably in World War I, the United States took over as the largest steel producing country. And after World War II, the United States controlled 75% of the world's steel making capacity. And the price of steel controlled the exchange rates between different countries. Does anyone know why the United States controlled 75% of the world's steel making capacity in 1946? We just finished what? World War I? And I mean, World War II. World War II was not fought on American soil. It was fought in Europe. It was fought in Japan. The United States had bombed out all the competition during World War II. And the only steel making left, by and large, 75% of it was in the United States. And so the United States was the king of steel, and steel was the thing that controlled the exchange rate between countries. What happened was in 1962, US Steel, which was the largest steel company in the world at the time, decided they wanted to raise the price of steel. And John F. Kennedy, the president of the United States, stood them down and said, you can't raise prices because that will create inflation around the world. That's how important steel was. And the president won, and US Steel rolled back their prices to the original prices. And some people say that was the beginning of the decline of the American steel industry. I don't believe that's true. I think it started in 1910. Okay, but we can talk about that. The country that took over in the 1970s, when I worked in the steel industry, was Japan. And Suzuki-san works for the largest steel company in Japan. They controlled everything from the 1970s through about 1995 or late 90s, when Korea took over as the world's largest steel. One company, POSCO, became the world's largest steel producer. And now Bao Steel in China produces, and I'll leave this for Suzuki-san, I'm sure he's going to talk about the competition with the Chinese. Well, competition is different than productivity. It turns out that competition has to do with exchange rates. But for a long time, steel was tied to exchange rates. But starting in 1962, steel started to lose its position as the commodity that controlled exchange rates in the world. And it switched, particularly by 1972, it switched to another sector. What was that? Anybody have any idea what industrial sector started to control the world's competitiveness in terms of exchange rates between countries? 1972 was the oil embargo. And all of a sudden, oil took over. And now when they talk about, in fact, it was in the Wall Street Journal this morning, the price of oil dropped below $40, of Brent crude dropped below $40 a barrel. That's what they use to define the value of exchange rates. And it turns out the primary currency in the world has been, for about the last 100 years, or nearly 100 years, the US dollar. And that puts the United States in a very unique position as the country that controls the currency by which everybody else measures the strength of their currency. Okay? That's beginning to erode. And the United States doesn't have the dominant position it had 20 years ago. And it's no longer just oil. What's the dominant commodity now that controls the price of virtually everything? It's not oil, but it's something close to oil. Anybody have an idea? It's energy. But oil is not the only form of energy. There's coal, there's nuclear energy, there's solar energy, there's Wind energy, energy in all kinds of forms. Energy is becoming what we call fungible. A plant that used to run on a utility plant used to run only on oil. And when the Arabs raised the price of oil, the utility prices went skyrocketing. But within 5 or 10 years, the utilities didn't want that to ever happen again. So what they did is they made it so all they had to do was basically flip a switch, and the utility plant generating electricity, which is a form of energy, could switch to coal, from oil to coal to natural gas or back. And so starting about 30 or 40 years ago, energy became fungible. It wasn't just oil. And we could talk about why it was just oil for a while, but it really became different types of energy. And then different types of energy fall into favor or disfavor for various reasons, some of them environmental, some of them political. But energy, the price of energy controls the world exchange rates today. People talk about things in dollars of oil or price of oil per barrel, and that's kind of the constant. So steel no longer has that dominant position, and Suzuki-san will talk about what's happening from his perspective as 40 years ago, 30 years ago, the Japanese steel controlled the world steel industry. And I'll talk about why the steel industry is so important to anybody. And why did China go after the steel industry? Why did Japan go after the steel industry after World War II and took it over? Why did the Koreans go after the steel industry? Why did the Chinese go after the steel industry? We can talk about those things. Does anybody, we've got a few more students, anybody have any questions before I get on to some other things? No questions? Does anybody have, well, I think Friday is when you're supposed to tell me what your topic is. It doesn't have to be a big write-up. I've had 3 out of 12 students that I think are taking the class for credit this semester tell me. So there's 9 of you that haven't told me what your topic is. But basically the 3 that have told me the topic, all they gave me was sort of a one-liner about what the topic was, and I approved those 3 topics. So it doesn't have to be a big, long thing, but I need to know, if you think you're going to tell me about the world's automotive industry, I think that's too broad, okay? And actually, I thought that the steel industry was too broad, but it turns out it's so important, and Suzuki-san will tell you about it from his position as working for a company that was once the world leader in steel and then lost that position to the Koreans and to now the Chinese, and the pressure that puts on the whole Japanese economy, not just the steel industry in Japan, but the whole economy. So steel is important enough that I allowed him to do a very broad topic, but I think he's going to talk about it from a somewhat personal perspective as someone who's worked in the industry for 15 years or so. Has anyone else picked a topic? Not yet? Don't want to give me a one-liner? Okay, it's due Friday, you know, okay? And we need to start lining up people who can give some talks. One person who's not on is supposed to give one a week from Friday, and anyway, we have to schedule some of the others. Okay, I sent out a few things this morning that we could talk about. We were talking about additive manufacturing, and I talked about a company that has now been valued at $2.5 billion, which was Desktop Metals. And there's going to be some very wealthy faculty members at MIT because of that merger and growth of Desktop Metals. And I kind of made some disparaging remarks about the technology. I think crap is a disparaging remark. Anyway, it turns out a year ago in maybe it's a year and a half ago, maybe it's 2 years ago now. In the fall, I gave a module on additive manufacturing, which is on my website. So there's 6 lectures on additive manufacturing, and we could talk about that. I have a couple of things that talk about additive manufacturing. We could talk about another topic I sent you was something about venture capitalists and how they're important for a number of reasons, but they also abuse the system at MIT. And it's something that's been going on for as long as I've been at MIT, which is over 50 years since I came as a freshman. So anybody have a preference today about whether I talk about additive manufacturing, codes and standards, venture capitalists at MIT? What would you like to hear today?
I would be interested in the venture capitalist thing because I took like one course on like entrepreneurship, and I was just interested about a little bit further into that.
Okay, so we'll do that because you had anybody else have a request today? If not, I'll do what I call money talks at MIT. So I'm going to share the screen, but as we do this, let me tell you a little bit about how this particular one came about. So this was last February, and you should be seeing a PowerPoint screen right now that says Money Talks at MIT, something I prepared this past February. And it was for a recitation. And we got into venture capitalists and why they're on campus and why there's so many of them, okay, on the MIT campus. MIT has a fantastic reputation. If you read my leadership management and education article in the faculty newsletter, the first couple of paragraphs talk about Thomas Edison said MIT produced the best people in the country, okay? I can't remember the exact quote.
Professor?
Yes.
My screen is actually, you're sharing just like a one white line. I don't know if other people are seeing that. I don't see the PowerPoint.
Yeah, I can see the slides.
You can?
Okay.
Okay. Maybe
you can?
No.
Well, let me stop it and try to start it again. Let's see if that works. Okay. Is that there? Is that working?
Now I can.
Okay. So last February, people were still very interested in the Epstein. It was all in the papers. And MIT administration was being hounded by people saying, how could you let this happen? And et cetera, et cetera. So I'm basically willing, I got tenure, I'm past retirement age, I can talk about anything I want, and MIT really can't do anything to me, okay? So I said, well, do you want me to, I don't know anything about the details of Epstein, but I know these types of things have been going on for years. And I said, I can talk about some of that. So I put together this slide about a company called Molten Metal Technologies, which was a scam in the mid-90s within the materials department primarily. But I start off with this story that actually I realized this was, I watched Hook the other day, the Disney movie, and Robert Williams actually told this joke, slight version of it. And he didn't say Harvard Medical School, but this joke says that Harvard Medical School announces it will use attorneys rather than rats in laboratory tests. And there were 3 justifications. Robin Williams only gave 2. Attorneys are more plentiful than rats, okay? The lab attendants do not grow attached to the attorneys. And the second and third ones were the ones Robin Williams had in the movie. There are some things a rat will not do, okay? So with that little attempt at humor, there's a similarity with university administrators, okay? And if anyone's ever heard of, you can look it up, there's the element administratium, okay? And it talks about the organization in a sarcastic way about how universities are organized, so far as that goes. Anyway, to get into molten metal technologies, now this part is a true story. It's not a joke, unfortunately. But in 1989, Chris Nagel was a doctoral student in chemical engineering at MIT and a former employee of US Steel. And he had founded a company to use molten steel as a method of converting hazardous waste into useful products. And you have this, you can click on these links and it will give you a news article about from Industry Week talking about molten metal technologies. So Chris Nagel in the mid-'80s had graduated in chemical engineering, had gone to work for US Steel, and he worked there. And as he learned about the steel industry, he learned that it turns out that steel at high temperatures is sort of a universal solvent. Just like water is considered a universal solvent at room temperature for all kinds of materials, whether it's limestone or plastics or anything, water will attack almost anything and will start to dissolve it. At high temperatures, steel will react with almost everything, not everything, but many things, most of the things in the periodic table, and will dissolve them, okay? And so Nagel thought, oh, well, we could throw a lot of our hazardous waste into the steel bath because they're making, at that time, they were making 300 tons of steel every half hour in huge, huge baths at 1,500 degrees centigrade. Just throw your waste in there, he thought. And he gave his idea to US Steel because they owned it as part of the intellectual property of his being an employee. But US Steel looked at the technology and they said, nah, we're not interested. But Nagel, not really knowing anything about the steel industry and why US Steel wouldn't be interested in this wonderful idea, decided to go back to graduate school at MIT. And while he's at MIT, he had applied for a patent on his wonderful idea, and he tried to peddle it to the MIT Technology Licensing Office. I don't know how many of you know the MIT TLO, but the MIT TLO survived on 3 patents from 1950s to 1985. And those patents were all starting to expire, and MIT had been living off the royalties. They were getting good royalties, but they weren't fantastic. But it was all coming to the close and of their monopoly from the patent process, and they were concerned. And so think about 1984, MIT hired this guy, or actually he came from Stanford on a sabbatical, and he was in the equivalent of the patent office at Stanford, and he said, you need to revamp what you do. You're being run by a bunch of attorneys, and attorneys want to know the end from the beginning. And Tom Eager has a quote that you hire an attorney to keep you from getting yourself in trouble, and the best way for an attorney to keep you from getting yourself in trouble is to prevent you from doing anything. Okay, if you don't do anything, you won't get in trouble. And so attorneys they were very conservative. They wanted to work out the royalty agreements before the technology was even proven. And industry wasn't going to do that. And so this guy from Stanford convinced MIT to fire all the attorneys in the technology licensing office and replace them with businessmen. And businessmen would be able to listen to industry and negotiate things with them, and they could worry about what the royalties would be once they've proven the technology. And the philosophy was that MIT didn't want to start businesses, but MIT wanted to get MIT's technology out there being used. And if it gets used, the royalties will follow. you don't try to worry about the royalties up front. You worry about getting the technology used, and then the royalties will follow after that. So in 1989, the MIT Technology Office was headed up by a businessman named John Preston. And John Preston thought this idea of Chris Nagel was fantastic. And the two of them started a company, and here's a couple of web things to tell you about it. And within months, they were worth $30 million a piece on paper. And there is, it turns out, a case study at Boston University Management School, which you can look up on the web. It's available free, about molten metal technology. And this is taken from that business school case study at Boston University. And Vice President Al Gore said that molten metal technology was a shining example of American ingenuity, hard work, and business know-how. It hadn't been invented at MIT. It was invented by some chemical engineer with a bachelor's degree at US Steel. US Steel didn't want it, but he came and peddled it at MIT. It can literally revolutionize our ability to deal with toxic waste, said the guy who was the Secretary General of the United Nations Earth Summit. He wasn't Secretary General of the United Nations, but he was pretty high in the environmental stuff in the United Nations. And so they developed a process. They kind of wrote this up, did some graphics, which for 1990 were sort of glitzy, not very glitzy today, but they called it catalytic extraction processing is born. And here's your molten steel bath. And they show the waste coming in from the bottom. That's because US Steel used a process in steel making called QBOP, where they would inject the solids in from the bottom at high pressure into this huge vessel. This vessel being 3 or 4 stories tall in the molten steel at somewhere around 1600 degrees centigrade. And out of that would come gases, which they would sell, specialty inorganics, which means slag and other stuff. They wanted to use fancy names rather than the traditional industry names, and metals. And this would all go to industry, and when industry was done, they'd feed it back, and you would have no more environmental waste. You just keep circling this stuff around. That's what they told Wall Street, and like I said, it got a lot of hype. On a scale of 10, this is a 13, Preston said in an interview with the Boston Globe in 1993. They went public in February 93. Remember, Preston supposedly is the top technology licensing officer at MIT. He's got the MIT name behind him. So if he tells the Boston Globe, this is a 13 on a scale of 10, all the people who don't know anything about technology are believing that MIT has now endorsed this company. Ultimately raising $350 million and employing 500 people. Well, nowadays, $350 million is peanuts. But, you know, back in the early 90s, this is 25 years ago, this was real money for a startup. In 1996, the company was in commercial production. They had a facility down in Fall River, Massachusetts, because the state of Massachusetts gave them this big interest-free loan or whatever, because Fall River was depressed and didn't have a lot of jobs and blah, blah. And they were now cleaning up the country's nuclear waste. I remember I heard about this when I was teaching a class at the Sloan School in the mid-90s. Before class, anybody have any questions? Someone says, what do you think about molten metal technologies? And I basically said something that was probably just about as disparaging as what I said about desktop metals, because I tend to speak my mind. And the students were kind of shocked. And then one of them says, well, they're going to clean up the nuclear waste. I said, what? That was the first I had heard about it, is in that, when I was starting to lecture that Sloan class. And anyway, the reality, and here's an article in the Boston Globe magazine, I think, What also helped Molten Metal was a cozy relationship with Vice President Al Gore, Vice President of the United States, right? Executives gave tens of thousands of dollars in campaign contributions to Gore, a likely 2000 presidential hopeful. Their big play was Vic Gatto. He was a Molten Metal executive, a classmate of Gore's, and a legend because Gatto captained the Crimson of the 68 Harvard-Yale game that ended in a 29-29 tie. What could be better scientific evidence that this guy was a successful quarterback in the Harvard-Yale game, right? Now there's real science, folks. Some believe that helped the company secure $33 million in federal grants from the Department of Energy. And it turns out Congress did get involved later in looking at that $33 million and whether it was obtained properly. Molten Metal then became the focus of a Senate campaign finance investigation into whether it got favorable treatment because of Gore. So all the things they're doing against Trump and the Republicans now, they were doing against the Democrats because Clinton was in office. It turns out Molten Metal started in '93. 4 years later, they were in Chapter 11 bankruptcy. Okay. MIT's involvement. This is from the Tech in 1995, which was a year and a half after they started. Gore was running for president, and he decided he wanted to come to MIT and speak at a town meeting, they called it, over in Kresge Auditorium. And he was going to talk about the environment. The environment was a big thing there. Mario Molina had just won the Nobel Prize. He was the guy who discovered the ozone hole in South America. He was a professor of Earth and Atmospheric in the Department of Earth, Atmospheric and Planetary Sciences. I actually was teaching part of a course with him. He's a wonderful person. He actually left MIT to go back to Mexico where he was born. And I think he's some big environmental minister in Mexico now. But yeah, Nobel laureate on the panel. You had Al Gore speaking about the environment, and he was running for president. MIT's involvement, aside from hosting this town meeting, many MIT faculty and administrators held stock in Molten Metal Technologies. If it was going to be successful, they were going to walk away with millions of dollars in their pocket. In the meantime, Professor Sadoway and Eager complained to the vice president of research that Preston had a conflict of interest. He was putting together this town meeting for Gore. And of the 4 companies he had, he was putting his company on the agenda. I thought that was a conflict of interest. The MIT vice president of research told me it was not, okay? Sadoway thought it was a conflict of interest. We were both told we were idiots. We didn't know what a conflict of interest was. MIT metallurgy faculty were on the MMT Scientific Advisory Board, okay? And they were going to make millions if it was successful. So MIT continues to have inappropriate relationships with venture capitalists in terms of Epstein and stuff. This has been going on. I mean, this example, Molten Metal, is 25 years old. And it happened before that. It happened 25 years before that. I can't go back more than 50 years, but I'm sure it's been going on even before that. Anybody have any questions thus far? Okay. I've given you the references. If you don't believe it, you can check out the references. This was all in the Boston Globe and other magazines and stuff. So why did U.S. Steel give up the patent rights? And why did Sadoway and Eager think this whole thing was crap? Okay. Well, it turns out we actually knew something about making steel. Okay. Most people who were doing this investing, they knew nothing about how to make steel. Okay. But it turns out there are people in the Department of Material Science and Engineering that knew something about making steel. John Chipman, for whom the department conference room is named, introduced the physical chemistry to high temperature physical chemistry to steel making. He's revered throughout the steel industry as someone who puts steel making on a good fundamental thermodynamic basis, okay? John Chipman was a wonderful man. I knew him when I was a student, as a young faculty member. It's true, molten iron at high temperatures is a universal solvent similar to water at room temperature, but molten iron must be contained in a refractory at 1500 degrees centigrade. And it turns out two of the things that will destroy the refractory are sodium and chlorine. And it turns out the refractory for the steel furnace basically needs to last for at least a year, and in the blast furnace, maybe 3 years, to have a process that's competitive with all the people who know how to make, other people who know how to make steel in the world, which is a lot of people. The steel industry is $1 trillion industry, okay, worldwide. Well, sodium and chlorine will destroy the refractory, and the refractory will last a month, okay? And if you have to reline every month, and it takes a month to reline, you're gonna have a loss of 50% in your $1 billion steelmaking furnace. And that's not necessarily a good thing in terms of the economics. Steel contains carbon. The definition of steel is carbon and iron. In the presence of chlorine, it will form something called COCl2, also known as phosgene. This was one of the poison gases they used in World War I, okay? And that's going to be coming out the top of the furnace. Those gases they were going to sell, I don't know that there's a huge industrial market for phosgene, but we would be producing a lot of it if we used molten metal technology. Small amounts of bismuth, antimony, and other semi-metals will destroy the mechanical properties of steel. And in the thermochemistry technology of making steel, which is what virtually everyone uses today, you cannot get rid of bismuth and antimony. Where's that going to come from? It turns out they recycle a lot of automobiles. That's what happens to old cars when they die. They recycle them, and they have lead tin solders. And lead tin, they can get the lead and the tin out, but they can't get bismuth and antimony out. And in the mid-90s, everybody was trying to get rid of the lead and solders, and they were replacing it with solders that were based on tin antimony and tin bismuth. And that means every automobile in the country would become junk, non-recyclable, because it contained these impurities. None of the people on Wall Street knew this, okay? Because they didn't know steel technology. They didn't know metallurgical thermochemistry. Sadoway and Eager did, okay? US Steel did, okay? So why did US Steel give up the patent rights? They knew this was a crappy idea. No one in their right mind who understood steel technology would invest in molten metal technologies, but they put it out there with the MIT name behind it, and they raised $350 million from all these people who believed in the MIT name, okay? And then they convinced the Department of Energy they could throw radioactive waste into the molten steel and get rid of the radioactivity. Believe it or not, go read some of the reports. How many people believe you can transmute a radioactive element by putting it in a hot metal bath? Well, that's what they were telling the US Department of Energy, and the US Department of Energy was giving them tens of millions of dollars to try it. Well, I call this the selling of the MIT name. When I first came to MIT as a faculty member, as assistant professor, I said, MIT gave me three things: a desk, a local telephone. Back then you had to pay for your telephone calls. Long distance calls were expensive. They weren't a free web thing like it is today. And they gave you the MIT name behind you. The only one of these things that was of value was the MIT name. And as I say, our job is to leave MIT with a better name than we found it. The venture capitalists hanging around MIT are exploiting the MIT name and have been doing it for years. And I said, is that different than what Epstein was doing? So that's why they're around. And it turns out the venture capitalists don't care whether the technology works. They just want the MIT name behind it to tell people, investors, oh, MIT developed this technology and you should invest in it. You'll be a billionaire next year. Well, it turns out that all they're doing is selling the MIT name, and they will make their money at the IPO, and they will leave your grandmother's pension with that much less. Okay, they will make plenty of money at the IPO. Everybody else, all the suckers and losers, as the president calls them, I'm not talking about the military here, but the suckers and losers are going to be the investors who believe that MIT can do anything, and if it has MIT people behind it. So I updated this in April. I wrote this in February, but I updated it in April because those who cannot remember the past are condemned to repeat it. George Santayana was a philosopher at Harvard University, and he made this statement, and it's been used many times by many people. And the repeating it is something that happened in March. It turns out there was a guy, Bouchard, okay, who wanted to start a company called Brady Metals, and they were going to make aluminum on a greenfield site in Kentucky that had a railroad track running through it. It was just a rural area of Kentucky. It was a couple of hundred acres, like 220 acres or something. They're going to build a brand new aluminum plant. And they were going to sell aluminum sheet for automobiles and trucks at half the price of all the world's aluminum companies. So Suzuki-san, you worry about what's happening to the steel industry. The aluminum companies were really worried that somehow Brady Metals had some super technology. And they tied in with someone at MIT, very, very influential in the MIT materials department. He was one of the founding investors. And this guy, Bouchard, it turns out at the end of January, the board of directors fired him because he had been lying to them. And it basically was sort of a Ponzi scheme, if you know what it is. Here's some of the articles. But it turns out that this investigation is all going on, but Bouchard had ties to the Russian mafia. If you read some of these articles, the people in Eastern Kentucky who are people that, you know, they are very Republican right now, okay? They think Donald Trump is wonderful, but they don't trust the Russian mafia. But Bouchard was basically being funded by the Russian mafia to help build this aluminum plant. And MIT's name was associated with it, okay? So you can read about these things. I gave you the molten metal technology example. You can compare it with Epstein, which some of you lived through. A lot of you have been at MIT for a little while. And you can read about Brady Metals, okay, which is another disgrace, okay, for MIT. And these disgraces, there are probably 2 or 3 a year, okay? They're not all in the materials department. Some of them are in other departments. At the same time, there are some wonderful technologies that are developed at MIT. Okay, Akamai Technologies. I remember I was on engineering council and some professor in math became a billionaire overnight because Akamai had the algorithms for searching on Google on the web in the mid-90s, which was a big new deal. But now it's a huge company, and we've got Genentech. We've got some real winners which give MIT its reputation, but we've had some big losers, okay? And if you read some of these things about molten metal technologies, you'll learn that John Preston was indicted, okay? Criminal charges for what these people were doing. So be careful of the venture capitalists around MIT. They're not here to help, they're here to enrich themselves and to use MIT's name to do that. They also are here to help on real technology, but they don't care if it's real technology. They just want to make their millions and move on. And if they help when it's real technology, that's great. But it doesn't matter. As long as they make it to the IPO, they sell their IPO, they walk away with their millions. And if it's successful, hopefully the world, MIT's reputation is enhanced. And if it's not successful, hopefully no one remembers. I remember when the indictments came for molten metals technology, I read the article very carefully. I wanted to see if MIT was listed. And fortunately, MIT was not listed when they gave the article in the business section of the Globe about the indictments for the people at Molten Metal Technologies. But how brilliant do you have to be to know that you can't put sodium and chlorine in a steel furnace? How brilliant do you have to be to know that you can't destroy radioactive metals at high temperatures, okay? This is not rocket science, folks. This is just venture capital salesmanship, and you should be very careful. Because many of you, I know about half of you, are interested in starting your own business. More power to you, but just be careful. These venture capitalists are not there to help you. They're there to make themselves wealthy. And if you can use them to take a good technology and make it better, great. But don't besmirch the MIT name while you're doing it. So there's my little lecture for today. Any questions?
Thank
No
you for
pressure.
covering that, Professor.
Okay. See, most people are not going to tell you those stories. Okay, but they're true. Okay, you can verify it. But this is one of the reasons my colleagues don't particularly like my telling the truth. Okay, sometimes the truth hurts. Okay, well, tomorrow we'll have Don Baskin lecturing again on lightweighting. And we're going to go ahead and use my email address because we still haven't figured out how to get him to be able to record without my being here to manage it. Any other questions? And I'll remind you, 9 of you, you need to give me a topic so I can start scheduling you. Okay? Thanks. I'm going to quit recording.